All right, so I already completed this whole problem and I recorded, but then I made a mistake entering it into my calculator at the very end. And now I have to redo the whole recording. So I drew a diagram of what's going on here. We've got a force P going downward of 10,000 newtons. And I'm calling the force of the hydraulic cylinder, I'm calling that Q. I'm also using some trigonometry such that if we know what theta is, then I'm going to call this phi. Whoops. I'm going to call this phi right here. And I can figure that phi is 90 minus theta. So therefore, if I ever write cosine phi, I can replace it with sine theta, because the cosine of 90 minus theta is the sine of theta. Likewise, the sine of phi is going to be the cosine of theta. All right. I also indicated gamma right there. That's my angle gamma. And in order to figure out the angle gamma, I use the law of cosines first. But let me just explain a little bit more. I wrote what L equals and what D equals, and I created variables for those two. And then I'm calling this 3D because it is 3 times D. It's 1.5 meters, which is 3 times 0.5 meters. So I just decided to call it 3D. So let's go down to the law of cosines. Down here, I use the law of cosines to figure out what D sub 2 is. And I'm calling this D sub 2, this length here. I'm figuring that once I know D sub 2, I can use the law of sines to figure out what gamma is. So D sub 2 is this. Remember, I saw cosine phi, so I just replaced it with sine theta. Then I can use the law of sines to figure out what gamma is. So that's going to come the whole way down here using the law of sines and combining it with what I learned from the law of cosines. All right. Over here, on the left, I'm beginning my virtual momentum. I need the y value of A, the y value of C, and the x value of C, which is pretty simple using trigonometry. I can take the derivatives of each and get the changes in YA, YC, and XC. Q has some directionality to it. Q cosine theta would be there. Q sine theta would be there. Move downward here. Okay, so I wrote my virtual momentum equation. P times delta YA, Q sine gamma times delta Y, what was that? Delta YC. Q cosine gamma times delta XC. Simplify that, and I get this equation. If I put this equation into a calculator, but for gamma, I substitute the inverse sine of 1 over the square root of 10 minus 6 sine theta times cosine theta, then it gives me an answer of 12,030 newtons. Now, it is very important that you set your calculator up for radians. So everywhere that I see theta, I need to put in 55 times pi divided by 180 radians. So theta's here, theta's here, theta's here, theta's here. I need to make sure that I use radians for everything and set my calculator for radians. Otherwise, your answer will not be correct. And that's it. 12,000